So these are some Rabi tests. The point is I'm trying to figure out if we can improve the range by adjusting the radio encodings and video encodings. So now I'm setting a very low power level, like 20 milliwatts, just so that I don't have to fly too far to have a bad link. Okay, let's wait now for rebooting. Okay, we rebooted, now we are good to go. So in the first part I'm just trying to find a location that is obscured by vegetation and stuff like that, so that we can have a bad link and then adjust the parameters to see if we can improve on that. Some of you might know that DJI is doing this with their system, so we are trying to see if the Raspberry hardware and everything we can implement something similar. So right now we are on a data rate of 18 megabytes per second and a video bit rate about 6 or 7 megabytes. So on 20 milliwatts transmission power we shouldn't have to go too far away to have a bad link behind some vegetation. So let's just find a good location for doing some tests. One thing to watch for is a bar graph on the right side that tells us pretty much how the link behaves. So the green bars are packets that are bad but could be reconstructed by error correction. The light blue bars are requests for retransmissions, and the dark blue bars are actually received retransmissions. So, and the gray, the transparent gray, it's data that it's fine. So as you can see, we pretty much still have a full quality link. So let's go behind some bigger trees and let's find a good spot. Okay, the link is starting to break up in terms of quality, but the video is still fine. We see a lot of retransmissions happening. Okay, so we are approaching a good spot here. We can see that even with retransmissions a lot of data could not be recovered. So the point is the retransmissions are retried for like 200 milliseconds. So after that we abandon a request for retransmission, otherwise we would get very long delays. Okay, so we did found our spot to do the testing. So as you can see, the link is very bad, it's unusable. Even with all the retries and so on, we have a lot of breakups. So now we should try to change the parameters to see if we can improve that. So there are two types of parameters that we are going to change. One is the radio data rate, which affects the radio encoding, and the other one is the video bit rate. Basically we are telling the H.264 encoder how much data to generate. So basically the lower we set it, the more blocky and less details we will have in the video. So let's go to something really low like DJI does. So we should get a very blocky video at this point. And yeah, let's decrease the packet size a little bit, because we are sending less data now, so We don't want a packet to span too much time. Also, we added a lot more error correction data, so that's the point. We want to make sure we had a chance to display even a low resolution video. Okay, so now I switch to 12 megabytes data rate. It's a little bit lower than it was before. Let's see how it behaves now. Okay, I'm going behind the trees. It seems to be better. I mean, much better. Yeah. As you can see, not even retransmissions are required at some point, but yeah, we can still break the link if we try hard enough. So probably we should try even a lower radio data rate. That's the point. When things go bad, we should do our best, so we should go as low as possible with the data rate. But yeah, still we can already see an improvement. So we are still on 12 megabytes. You can see in the top right corner the actual data rate that we receive from the drone. Okay. Now let's go even lower in the data rate. So 6 megabytes should still be enough for 4 megabytes video, including error correction and everything. So let's see how it behaves now. Yeah, some retransmission still happening, but I would say the link is usable. Maybe we should, I spoke too soon. Yeah, I mean, at some point, not even any recovery mechanism will not work if you don't have enough power. So overall it seems better, but maybe we could adjust a little bit the error correction. Maybe let's add some more error correction. Yeah, and I decreased a little bit the video bitrate, so with 1 megabyte video bitrate and error correction is almost twice as that, so we should be transmitting with 3 megabytes on a 6 megabytes data link, so we are still good. We are not overloading the radio link. So here I'm checking all the other parameters. They will not have a big impact on our tests, but let's give some more room for retransmissions. Okay. Okay, now let's go behind the trees again and see how it works. Again, we are on about 20 milliwatts of transmitting power, so yeah, I think we are in a spot where we are really blocking the link. Let's try to find a different spot maybe. Yeah, let's try one more time with a bigger packet size. So a packet would span a longer time frame, so to speak. So we should have better chances for error correction using bigger packet sizes. Yeah, it seems okay. Given the conditions, 20 milliwatts and a lot of trees. So even for 1 megabyte of video bitrate, I would say the quality it's better than I expected. I expected to be more blocky, so to speak. But anyway, the point is we want to see if the link is usable, even if the video quality it's not great, but it's flyable for sure, as it is now. Yeah, it's more like analog video now in terms of details. So let's try to do some flying around and then we will adjust back to the higher parameters and see if it breaks up. So I mean it should. So now we are on the lowest quality and the lowest data rate we could go, which would give us the best chance to have a consistent video link. Now let's go back to the regular video and data link. So 18 megabytes data link and 5 or 6 megabytes video bitrate. Okay, I think now we are good. So let's fly to the same spot and see if it breaks up, going through the same flying path. Again, the thing to watch is a bar chart on the right side with the video packets. Green is error corrected packets, which are fine. Light blue are requests for retransmissions and dark blue are received retransmissions. And red, of course, it's bad data that we couldn't recover. Yeah, okay, as expected. So with a full quality link flying through the same location, we have a lot of retransmissions and broken data. So this validates our test. It means that probably we could try to do something similar with what DJI is doing when the quality goes down, the link quality. We are doing our best by decreasing the video quality and going to a lower radio encoding scheme. Let's do some more flying around to actually see if that's the case. So now we are on full quality link. We should expect a lot of breakups in the video. Okay, I'm trying again to switch back to the low quality stream and low encoding rate to see if we actually have a stable video by flying through the same location. So video bitrate was set back to the lower 1 megabit per second, and the radio data link was set back to 6 megabits per second. So now let's fly and see if it breaks up and how many retransmissions happens and so on. Yeah, seems to be better for sure, which is a good thing. That means we could try to implement this link behavior. What you cannot see here is that actually from this point to the ground station there is a small wood house also in the way, so not that it really matters, but it's a hard, let's say it's a hard blocker in some position for the radio link. But overall, yeah, I'm pleased with how it works. So those tests are successful. The hard part is now to figure out when to actually do the switching algorithmically, because you don't want to do it too soon when you just have few retransmissions happening, but also not too late, so that the user does not have a long breakup in the video. But I will have to see how I actually implement this automatic switching when. The hard part is of course figuring out when to go to the lower quality stream. Going back to the full stream, it's easy if you just have a good link for a few seconds. You can switch back to the high quality one. We'll see. So it's not covered here in this test. I actually did one more flight, but I forgot to record it, where I did not fly behind vegetation, but I have flown away, high and away, like 500 meters away and 500 meters altitude, using the same radio power, 20 milliwatts, and the results were even better. I mean, with a full quality link on 18 megabits data rate, I was able to go to like 400 meters altitude before retransmissions started to happen, and by switching to the lower data rate and the lower video quality, I was able to go to 600 meter altitude and 600 meter away, which is a clear improvement over the regular video link. So I'm happy with the results of the test. Yeah, probably I could try to go even lower, like maybe half a megabyte video bit rate and more error correction and smaller packet size, but I will do probably some more tests as I implement this functionality. So yeah, going back to the full stream, we have a lot of breakups in places where the lower quality stream worked fine. So those results are good. Means we could try to actually implement this. Some people requested this functionality, and I think yes, it would be a good one to have. Yeah, for now I'm not concerned about overloading the video link. That's not the purpose of these tests. So okay, so the battery is getting lower. Probably I will prepare now to come home and land. Let's do some flybys on full quality link. Again, this is using a 5-inch drone and a HQ Pi camera. I'm really pleased with how it looks, but yeah, it's a camera sensor, but I guess a big role is played by the lenses. They are quite big, made of glass, and probably it's good optics in them. So anyway, that's all for this video. So thank you for watching, and looking forward for more tests and actually implementing this. Now I will leave you with some flight statistics. Bye, thank you.